Good morning, everybody. It's 12:36 in Boston, and I want to start my coding. Let's do it. Morning is a mindset. It starts whenever you start your work. All right. Now stop being delusional and start the work. So we are doing it for the R positive. You remember, right? The intersection of the ellipse and the curve. No huge change in the problem. Oh, there is a problem. There is a change. What is the problem? When lambda is r over f minus r, we have y sigma infinity, which will never happen, by the way. So it's stupid. Interesting thing is that in this problem, so we were talking about our bisection method, right? When r was negative, what was happening? We could always start from 0. Nothing was all of sigmas were finite, and we could start from 0. Our m could theoretically go to infinite, but m equal 1 was enough for our simulations, which was really good. We didn't have any trouble there. Now, for the R positive case, let's see what we have. Okay, you don't have me. Control Shift 2. So for R positive, the curve starts from lambda equals r over f minus r. It is nope, not here. Okay, the formulas are the same. So sigma ai omega, lambda is positive, but lambda is greater than r over f minus r. Why? Because we want nu to be positive. Remember, both of them are binding, by the way. We know that. And if we start right from r over f minus r, sigma I omega will be infinite, which means ellipse is r over f minus r definitely will be outside the ellipse. So the thing is that if I want to start my bisection method from the starting point r over f minus r, sigma I omega will be infinite. Definitely we will end up outside the ellipse. So what should I do? Should I say lambda is r over f minus r plus epsilon? To be practical, maybe it's a good point. And we choose epsilon very smart. By the way, notice r can be very close to f when r is positive. And r over f minus r can be very big number. So it's a good thing to have something in mind for r over f minus r, the starting point. If you have the formula, look at the formula for the ellipse. What's happening? Share. So that's the only thing. Otherwise, all the formulas are the same. And also our code, if you look at it, I'm returning like infinite for y, when our cubic equation is this, like when lambda is r over f minus r. But we don't never want to have that. We never want to have a situation where we have infinite because it's unnecessary. So, do we have smart view? All right. So what is it? What is the equation for the ellipse? I think the equation from the ellipse can give us a hint. Maybe we don't need to start from r over f minus r. I don't want to spend too much time. I think it is a minor mental masturbation here. We better run the code and see how it goes than trying to have the code, because this is going to be the best code ever. Okay, this is ellipse, right? So when lambda is r over f minus r, exactly here as we have it, sigma ai omega here goes to infinity. One thing we can do is just setting the term for sigma ai theta I at its minimum, right? And see what is the biggest sigma ai omega we need. Find a lambda that works for that and do that. Okay, let's go. Good idea. Very good idea. I want to see what is the biggest sigma ai omega I will have on the ellipse. Find a lambda that on the cubic curve matches that sigma ai omega and start from there. Okay, if I can open a new overleaf. Overleaf. Do we have the formula for the ellipse in the general form? It's here. So x0, y0, we have all of them. X, what is x? So that's the thing we want. Now I want to say, let's set x as x0, right? What will be the y? And what will be the lambda that generates that? Where is oh, okay. So very quick. I'm okay to upper bound everything here, to be honest. So this is the ellipse equation. 1 plus r t squared sigma theta I squared t squared sigma theta I squared x minus x0 squared plus no, that won't work. We cannot set x as x. Actually, we are going to set x as x0, but we want to find the y and put that y on the cubic curve. R squared the square sigma omega. By the way, sigma AI omega over S sigma omega squared will always be positive, right? Yes. So y is positive. What is y0 though? Y0 is also positive. And it is, shit, this sucks. And it is something close to infinity. So I think there is no point, right? My way was to say, like, let's set x as x0, find y minus y0, that sets this. But all of these terms, even on the right hand side, if you look at it, all of these terms have 1 over f minus r. Well, okay. Every time we are solving, we are not solving for an r that is approaching to f. That's the thing. Every time we are solving, r is a constant, so r minus f minus r, 1 over f minus r may be a big number, but it's not converging to anything, it's just 1 over f minus r. At the end of the day, it's a number. The problem is with lambda. Is there a problem with the lambda? Actually, there is no problem with lambda too. Fuck it, let's go just do it. Because lambda starts from f over f minus r in our code. Well, it's a big number, so what? Let's see how it goes. Which code is this? This is the collaborative. Alright. M is 1. Well, M should change. Oh, okay. If lambda is r over f minus r, sigma I omega will be infinite. I see, okay. So lambda can cause problem. R cannot cause problem. Guys, R cannot cause problem. But lambda can cause problem once it gets close to r over f minus r. And sigma I omega will be infinite. So, okay. I forget, I mentioned it so many times, but so let's assume, okay, let's just have a quick thought on this. F y minus y0 squared equals t squared sigma theta I squared squared plus if r squared is squared sigma omega squared for f minus r squared. Oh. Here r is constant, alright, but lambda can vary. So, okay, let's set, I'm not writing for you. So let's set x as x0, right? We are on an ellipse. This is x0, y0. We know we are outside for y lambda. If the lambda is r over f minus r, the sigma ai omega, the y will be definitely outside. We will be outside the ellipse, right? And we will be on the upper half for sure. So it will be upper half right here, above this, right? It will be somewhere here. I want to set the x as x0, right? That's what I want to do. I want to set the x as x0. So this is not a good color. So this is x0, y0. If I set x0, if I find the y at this point, then if my starting point, the gamma star in the algorithm sets y, any y greater than this y, that is not infinite, works for us, right? So I want to start from somewhere here and go there. So let's set x0, and we want y minus y0. We know we are y, by the way, when lambda is r over lambda r over f minus r, y is infinite, right? So y minus y0 is also infinite. So we are on the upper half. So for at the beginning point, y minus y0 is actually positive, and it's greater than square root of this, right? So when we set x as x0, we will have r is r squared sigma omega squared over f y minus y0 squared equals that, which is less than something upper bound that shit. R is, again, R is less than 1. So it's less than 1, t squared sigma theta I squared. I can say 4. Here I want to keep f minus r plus and 4 f minus r squared, and for that one f is also less than 1, so s omega s squared sigma omega squared. So I can say less than 4, like 2 times max of t squared sigma theta I squared and s squared sigma omega squared f minus r squared. What can I say this side? R is definitely, r can be close to 0 too. So I will keep r squared. Actually, there's no problem with that. So f, I can say fuck f. Y minus y0 squared. Max 4 so I can remove f, right? Because f is less than 1. at n2 f is 1 and greater than b is less than 1. It's actually less than 1/2. Actually, I can say this over r squared s squared sigma omega squared. So y minus y0, again I can say less than, I want to remove 4 and 2, f minus r squared max. This ratio we had it before, right? T squared sigma theta I squared over s squared sigma omega squared and 1, right? And then I want to say y minus y0. I can take the square root y because y minus y0 will be positive, less than f minus r times r max 1. Well, this is t sigma theta I definitely over s sigma omega and 1. And y0 also has a term f over 2f minus r. So y is less than f over 2 times f minus r plus max ratio s sigma omega 1 f minus r that's it. So y is less than f over 2 is also less than 1. Oh, we have an r term here too. Okay. Well, it is definitely less than f over r, f minus r, because r is less than 2, right? Greater than, less than 1 over n minus 1. Alright, so this is also another upper bound, max over r f minus r will be less than max plus f over r f minus r will be less than t sigma theta I. Yeah, that's true. Over s omega plus its inverse t sigma theta I over rf minus r. Does it give us any hint? Y is sigma ai omega s sigma omega squared. And we know sigma ai omega from the curve is, now let's go to the curve. Now if we go to the curve, sigma I omega over s sigma omega is 1 over 2n lambda nf plus 1 over lambda f minus r minus r. So if we set this as m, n, or capital N, right? 1 over 2n lambda nf plus 1 lambda f minus r equals n over r f minus r 2n n, and which n is this number? That's not a big thing. N. Okay. Lambda nf plus 1 r f minus r equals 2n n lambda f minus r. What it gives us about lambda is lambda 2n n f minus r minus r f minus r n, right? Lambda f again, 2n n lambda f minus r minus nf r f minus r equals r f minus r plus r 2n n. So lambda times f minus r. Interesting, we again have f minus r, and we have n actually here too. 2n minus okay, lambda n f minus r, 2n minus rf equals r. By the way, rf is not a big number. Rf is at most 1. So 2n minus rf definitely bounded. No big deal. Rf minus r plus r 2n n. Okay, lambda will be n 2n minus rf. Sorry, over r n 2n minus plus r 2n n f minus r to n minus rf, right? At the beginning we wanted to start the algorithm with r over f minus r. Now this one suggests that this is even a good lambda, which for sure we won't have any problem for it. Yeah, let's do that. Let's set it as this. Why not? We did it, let's start having it as the lambda. Feels good. We are safe. You cannot have this issue. A, so instead of A being this, we said R over N over, well, okay, let me define also N as ABS. Do we have a? Yep. ABS T times var theta theta. Over S over var omega sorry, half plus the same inverse 1 over, let's see, so V, and here I want to start A as R over N over 2. I think this is more beautiful, N times 2 N. By the way, yeah, N doesn't, N is a constant. N minus R times F plus R times 2 times N times N over, well, just, yeah, okay, the N and N cancel out. Should have stopped kidding. R over N to N minus RF to, let's have some taste, 2R N over F minus R to N minus RF. And V, let's say 100 times A. Huh? If ellipse is positive, it means that we are outside. Negative, we won't be negative. If it's not, what are we doing? We should, M is not big enough. Good. So let's go check the code again. by the way, can we find the lambda that upper bounds for B? Same way we did it here. Yeah. Y that makes y0, right? We're sure. Let's have a constant B2. That definitely works. Maybe I am just making the code inefficient in a sense, but again, let's get back to our ellipse, right? We know we are starting somewhere on the top half here, right? For example here. And we are at the beginning outside the ellipse. This is x0, y0. So for sure, a starting point that ends up us with having a y greater than y0. Sorry, y0 plus this radius is outside. Now, at the end, we wanna end up somewhere cut, like B is somewhere here, right? For B, the Y should be in this top space. But we know that for any B, if our Y is Y0, if we are on the axis, if we are on this axis, we're definitely inside, right? What is happening? Clear all of this shit. Okay. So y equals y0. What y gives us y0? We have it. Let's go to the clean notes we have here. Y0 is f over 2f minus r. Y0 is f over 2f minus r, and sigma I omega over sigma s sigma omega squared equals lambda nf plus 1 2n lambda f minus r, right? So our y is always bigger than y0. So y is greater than y0. F over 2f minus r greater than this lambda nf plus 1 2n lambda f minus r, right? Let's see, 2n lambda f minus r f 2 f minus r lambda nf plus 1, right? We can cancel out 2's, and lambda f minus r minus, okay. 2 and 2 cancels out. Lambda times nf f minus r minus nrf should be greater than, oh my god, this sucks, lambda nf f minus r plus f minus r. Well, okay, lambda cancels out. So y0 is too low. Okay. Yes, this side is positive, this side is what? Our y should be greater than, yeah, actually our y should be greater than, so, which is always true. So fuck it, doesn't matter. There is no lambda that takes us that far. That's what it is. If lambda is infinite, we will go to n. We will go to nf over 2n f minus r. Yeah, actually, lambda infinity takes us to this ratio. So it's always true. Okay. Don't touch your phone! Where am I? Yeah, code. Let's go to the code. Sound good. Epsilon is this. M is this. N is this. I want to make this one looks better. And so this one as well. Then we have cubic. This line won't be used at all because now our lambda is always greater than r over f minus r. Then we have our ellipse, xx, yy, dd is delta. It won't happen, delta should be 0. L is np dot array, r in, so we are in the positive side, and this is our step. A is the lower point we just found out. That's something like that, bigger over the r over f minus r. Hopefully this works if x and y. And how far we want to go at the starting point. We set this number. We could set any other big number, but because r can go very close to f, I just set 100 times bigger than a. And x and y is less than 0, means that b is inside. As long as b and a, we want to make the interval smaller and smaller. C is the middle of the interval. We find the intersection of the, what is cubic C and R? So C will be the lambda, okay, alright. And for that lambda, we will have the curve x and y and r. If we are in less than 0, it means we are inside. We should take the left hand side of the interval, right? K less than 0, A is A, B is C, exactly. K is 0, we're good. K greater than 0, we're outside. We wanna go inside, so we wanna get C as A, B as B, and X. Okay, dd doesn't matter here. Still we are. Okay, we are appending 0, which is good. Should be a yes. So this is the while loop. happens and it finishes. But do you think this and these, they are not? Okay, this is for B, which is right. If it's here, we will get inside at the end of the while. Yep. Else, what is else saying? Print interior point. It will never happen. I don't think we will have that problem. XC is the other stuff. What is this? Yeah, I don't think we will have interior point problem. We may have M not big enough problem, but okay. What is the range now? Can I do it? Can I start the code? Can I run the code? I think I can. Let's go, let's see what's up. What is it? Cubic, invalid syntax, L and R. What is wrong with it? Well, we had it on the other code. There was nothing wrong with it. This is exactly the same thing. What is wrong with it? np.max. I'm just adding this. I don't even need this. I will bring this one. What? How is this invalid? Definition is invalid. So this one should be invalid too. It's not invalid. How is that invalid there? ChatGPT. ChatGPT. Where do I use cubic first time? Okay, there is a missing parenthesis at the end for the end. I can see that. Indentation is wrong. Why is it wrong? In the cubic function, you seem to be missing a closing in the calculation of n. Cubic, where is n? Line, what line? Where is it? Let's just give the cubic. Dude, okay, you're using C. No, they are bullshit. What is this, right? It is correct. Sent from somewhere else in your code or the context in which you're. You should check if there is unmatched brackets. What is wrong? What is this, by the way? 0 and backslash. Okay, these are the insert functions. So this is the problem now. I get it. Runtime error. Yeah, we are dividing by big numbers probably. That was something we were scared of, right? F minus r, 1 over f minus r is a big number. What if we said still, okay. Let's print R when it's happening. So even for r equals 0 we have problem. Oh, okay, why? There's something in the cubic equation that we don't have r. It will look like that. Oh, man. So it says I see. Okay. So we should multiply by r squared. R squared first of all, I don't know why we have r squared times 1 plus r np dot array. X is just coefficient of the r squared times that shit. And I can see that now. So maybe once we move the r squared inside, 1 plus r, this over r squared will be removed, and division by 0 won't happen. Do you want to do that, guys? So we are going to multiply everything by r squared. Let's see if this works. Mm-hmm. What's wrong with r squared? Zero size array to reduction. Operation maximum, which has no idea. What's wrong with the coefficient matrix? So r squared is shifted inside. All good. When r is 0, coefficient is let's say print coef. Okay, our problem is not r close to f, is it r0? Oh, it's all 0. Why? Coef, where is it? How can it be 0? What is lambda, by the way? R. Exactly. This term is 0, this term is 0. Wait, how can this be 0? Oh, even for r over f minus r is 0. Okay. Guys, even if we set a as something else, right? When we were designing the code, we were writing the code, we were focused highly on r close to f. But for r close to 0, we have the problem. And for r over f minus r, it will be all 0. So what are we going to do? Wait a second, what happened in the competitive part of the story? So we don't let, yes. The thing is that we don't let r be 0. Probably for r equals 0, which means that the actions do not the other person's utility, and everybody is just playing separately. We have a special case situation. All good. I want to set E. Just do a lot of Control Z. It's been a minute. Okay. A lot of cases where M is not big enough, so we cannot get into inside of the ellipse with like 100 times A. What do I say? 100 times R. 100 is over F minus, instead of R over F minus R, F minus R. That's okay. Yeah, dude. That's it. Take it easy. Why do we care so much? We thought starting point mattered. Do you want me to put it R over F minus R? What if I said it 1 over F minus R? Let's try it. Instead of R over F minus R, well, what was lambda? F over F minus R. F or R? R over F minus R. It's always a bit greater than R over F minus R. If it is R over F minus R, V will be infinite, right? Where is it? If it is R over F minus R, this will be infinite. But if it is F over F minus R, we are good. Yeah, that's actually a good point. And then for B, we want to be 100 over F minus R. Yeah, we just want to have a starting point scaled by F over F. Oh, okay, so we have a lot of interior points. What does it mean, interior point? It means that the starting point, we just started from somewhere inside. Really? What if I cannot set R over F minus R, right? Yeah, I cannot set that. What if I say R over F minus R plus E? That is actually a good point. What about when R is very close to 0? Let's do it anyways. Yeah, dude, works. I told you guys, all those big computations, stupid. Always do the thing. If something happened, we will fix it. This is a fucking code. It's not human beings' life. If something bad happens, we will fix it. Okay, this is it. And we want to also deal with R0. Okay, what are we plotting, by the way? We don't want a DD. We want XX, which is sigma I theta I. And we want YY, which is the same shit. How can I red and blue it? There is a bit difference. I think I just need to put R and they're the same thing. That's very stupid. Why do we have interior point? Interior point means A is small. For A0, it is always outside. Oh, it's not a problem. Okay. Okay, it's not a problem. For R negative, we can have situations that start from interior point. It's all good. Interior point R. Yep, it's all good. Okay, now R0. What happens when R is 0? Let's do this one too. By the way, I wanna match these two codes together. Let's do the R0 first. Oh, okay. When is 0, this, we don't have this. We don't have this partial derivative by definition. There is no r0. When r is 0, there is no you know what I'm saying, right? What changes though? When r is 0, all of this stays. Obedience changes a bit. Sigma ai squared and sigma ai theta j. Okay, sigma ai theta j has an r element. Yeah, you cannot remove sigma ai theta j once r is 0. When r is 0, there is no externality between the firms. That's what it is. Is it actually worth studying or no? By the way, yeah, right? We want to see if it is. This r0 takes us to the right to the beginning. Maybe we don't need to study it at all because it's not interesting. It's too simple. So when r is 0, your best response only depends on your type and omega state. So it's like selling data to a one data buyer that is just, right? Giving information about other people's theta doesn't help you, doesn't hurt you. And everybody is isolated, so there is no point. However, okay, this is the code. Now what I'm gonna do? The question is, shall we mix collaborative and competitive together so we can have a code for different values of R? I say no. If we want it, we can do it easily, but I say no, let's separate collaborative from competitive. And well, we had a graph before. I don't think it is for all ranges of R. Oh, well, actually it is. What is it? R, yeah. So if we want, we can mix. Competitive is R negative. Collaborative is R positive. So it's just a bit of difference in the for loop. Let me start a new code. Where is the best code ever? This is the best code ever. starting from where r is negative. Actually, yeah, we changed variance of omega to make it having interior points. These are all good. And print. We don't want this print anymore, but this one we want it. Okay. That I don't want. That I don't want. I need a break here to write if m is not big enough. Then I'm gonna collaborate. dd exactly will add 0. M is not enough, we should break. And we don't want these anymore. C. It is the right delta, right? No, delta should be 0. For R positive, we want always to be outside. Okay. Mm-hmm. Now plotting. Wait, why are we printing R? When are we printing R? While we don't have any. Okay, here we have R. My tablets, my Samsung big screen, shiny screen tablet stack. I need a break, guys. I think the code is running. Just let's plot it. So for plotting, we just need to have the R axis, which is the concatenation of these two NP arrays. Where is R? No. R is. Can I just do? How do we append? Yep, that's the best idea. np.append. Can you remind me what was the syntax for adding label? Oh, X label, Y label. No, but for legend. So this is big, but like compared to the other side, it's nothing. I see. And what else? Delta. Interesting, right? I love it. So this is the code I want to add. Let's go there. This is just optimal revenue. Hey guys, okay, that's it. Let's rename it, because you know, if I say best code ever, it will say, wow, you are such an arrogant, smart person. We know it's the best code ever, but once you do the best code ever, you want to have another code that is best code ever. It was a good experience. I love that we are doing coding. I love it. PLT, we learned it. I wish we can do machine learning, revenue. I will call it revenue, rename. And I wanna download it, right? Save file, save as, save. Yeah, exactly, here, save. Enter notebook path relative to, so I don't know what I was talking about. File, download as. .py. X. Guys, don't read my personal stuff, okay? I asked you. I asked you. Don't read my personal stuff. And I'm happy that you listen. Where is it? Python's research. Gaussian. Revenue. Let's go. Now let's go here. I want to delete. So this code.py, we have a benchmark. We have a competitive optimal revenue coordination presentation. Let me remove this one. Delete. We want to upload. Okay, is it there? Revenue. Can I move it here? No, why not? Okay, let's refresh. Yeah, it's here. Alright guys, thanks for watching. I have to go to my PT, by the way. Let me also confirm. And you know what? We have a bit of a time, so why don't we play counter with 10 minutes? 10 minutes. Wait, do you have me or not? Yeah, you have me. My sister is calling me after counter. Let me tell her I want counter. I've never texted my sister I'm on YouTube. That was funny. That was funny. I'm on YouTube. Okay. Yes, play, man. What are you talking about? Let's go, Dust. Let's go.
Let's roll.
Alright. Guys, I didn't upload much these days. Tags also. Ooh, what's happening, dude? How many people?
Activating the
Shit, look at his gun, dude. He has all
bomb
these
has been planted.
labels. It makes the gun stronger. Who could have thought that? Adding label to your gun makes it stronger. Damn, this guy jumps high, dude.
Bomb has been defused. Counter-terrorists win.
Can I add these guns if I kill or find their guns? Let's take this one. Hey, this doesn't look good. This is not a cool. What are you doing? Ooh! Just one of us or two of us. Ooh! What the fuck, motherfucker? Show some. Guys, this side we are dying. Oh shoot, dude. I killed him. I didn't kill him, but he was hurt. Guys, I don't wanna die. I will be back. Okay. This bro really helped. Dude, okay, look at this guy. Damn. I think he made his gun with this logo parts. Yeah, kill him. Who did it? Wait a second, why does he have cards here? Like above his photo, he has 3 cards. Yeah. I had 1 assist. Okay, that's good. Yeah, kill him. Ah, yes! Fuck it.
I'm in position.
No, escape. That's what I want. Let's go, guys. I'm helping you here. Alright. Oh, like, wow, okay. Who are these guys? He has 2 cards. Oh, okay. It is the number of kills. Alright. Every time you kill him. Yeah, kill him. fucking guy knows how to play the game. Oh shit, they are there.
Bomb has been planted. Throwing fire.
Yes. Oh, okay, we got this now. Okay.
Terrorists win.
Yes.
We are the best.
Wow, look at his, even his knife. Even his glove. How can do they? Oh, no.
Let's go.
Dude, let us arrive. Who are you killing? Oh, shoot, bro. They killed us. Dude, let's come this way, huh? No? What do you want? I loved it. It was back. Ooh, this is a party here, guys. Nice job. I was chasing. Woo! Motherfucker again, guys. I have to leave. Ah, yes! Happy we killed him. Guys, thanks.